Welcome to Library Seminars, a NOAA Central Library educational platform for the presentation of research and ideas in support of the National Oceanic and Atmospheric Administration's mission. Today's presentation is the last in a four-part series sponsored by NOAA's Office of Performance, Risk, and Social Science that focuses on climate equity and environmental justice. Kelley Bonner, NOAA's Workplace Violence Prevention and Response Director, will introduce our two speakers and tell us more about the goals of this webinar series. But before I hand over the mic, here are a few logistical details to help you enjoy the webinar. If you're having troubles right now with the audio or visual components of GoToWebinar, we suggest that you log out and rejoin us. This will generally reset the software and often resolves most technical issues. Our presentation is being recorded and will be available later on today on the NOAA Central Library YouTube channel. I've added the link to the channel in the chat box. Audience members are all muted. However, questions are encouraged, and we ask you to type them in the questions chat box, which is located on the right side in your control panel. And you can enter these questions throughout the presentations as they come to you. So let us know to whom the question is addressed by indicating the name of the person you'd like to answer it. And then at the very end of the two presentations, we will do a Q&A with both presenters. So with that last detail, let's get started. The mic's yours, Kelley. Thank you so much.
Thank you so much. Welcome everyone to, as was brought out, the fourth of this series on climate equity and environmental justice. As you know, this is really part of a larger goal for NOAA. It's really twofold. One, to educate us as a community about what's going on in the science world and on this topic particularly with climate equity and environmental justice, but also for us as a community to better serve the vulnerable and underserved communities that we engage with every day. Ultimately, by listening to the speakers that we have today, and we have two wonderful ones, we are trying to generate best practices and collaboration opportunities as NOAA really moves forward to embed equity and justice into everything that we do. So let's get started, and let's introduce our first panelist, who is Dr. Yaítza Luna-Cruz. Dr. Yaítza Luna-Cruz is an atmospheric physicist. She has spent most of her career working in operations for the DoD Defense Threat Reduction Agency Technical Reachback. In her role as a subject matter expert in chemical, biological, radiological, nuclear, and explosive transport and dispersion modeling, and she's developed critical real-world natural hazard modeling. She was able to support 24/7, 365-day operations planning and research and development efforts for both federal and international agencies. During the last few years of her career, Yaítza has served as a product and project manager for Jupiter Intelligence. This is a climate change analytics company. Now, most recently, Dr. Luna-Cruz joined Agile Decision Sciences to support NASA's Earth Science Data Systems program located at headquarters. Yaítza earned her PhD in atmospheric sciences from Howard University in Washington, D.C., and her bachelor's and master's in physics from the University of Puerto Rico. As a Latina in STEM, Dr. Luna-Cruz is a passionate advocate for diversity and inclusion. Yaítza was also recognized as a leader through her student years, being a founder and the first president of the AMS student chapter of the Caribbean. She continues to be a STEM ambassador through many outreach and mentorship activities. She's also an active leader in multiple American Meteorological Society boards and committees, and currently serves as the AMS Women's Chair under the AMS Board of Representation, Accessibility, Inclusion, and Diversity. Dr. Luna-Cruz is one of the senior advisors for the Puerto Ricans in atmospheric sciences and meteorology. So with such a glowing resume, let's listen to Dr. Yaítza Luna-Cruz as she educates us today.
Thank you, Kelley. Good afternoon, all. Today, I'm presenting on behalf of the NASA Earth Science Division. As Kelley mentioned, I serve as the support scientist for the Earth Science Data System program, but I also represent the program co-leading on initiatives to understand NASA's role in addressing environmental justice. I work with an amazing team to include Aaron Pina from Research and Applications Program and Nancy Survey from the Applied Science Program. The NASA Earth Science Division commitment to equity and environmental justice is aligned with two executive orders. Number one, advancing racial equity and support for underserved communities through the federal government. And number two, tackling the climate crisis. NASA's Earth Science Division not only aims to diversify earth science research and applications communities with representation from all backgrounds, but also to support EJ communities by expanding awareness, accessibility, and the use of earth science data. Expanding awareness, accessibility, and use of earth science data is our current focus area, and I'm going to be talking about the four main goals we identify as our short-term plan for the next 18 months. Before moving forward with our goals, it is important to define some concepts. Following the Environmental Justice Advisory Council, our definition of environmental justice is based on the understanding that the use of NASA data, products, and personnel can and should inform the just treatment of meaningful involvement of all people, regardless of race, color, national origin, income, or ability, with respect to the development, implementation, and evaluation of programs, practices, and activities that affect human health and environment. Likewise, we are adopting the definition for EJ communities as geographic locations within the US and its territories with significant representation of persons of color, low-income persons, indigenous persons of members of the tribal nations, where such individuals experience or are at risk of experiencing higher or more adverse human health or environmental outcomes. It is also important to mention that while the focus of the Earth Science Division EJ initiative is currently on the US and its territories, we recognize climate change, disproportionate influence, environmental exposure, and vulnerabilities of marginalized communities referred to as climate justice. Now that we define the main concepts in our focus area, let's talk about the goals. Some of them are already in progress, and they will be extended, as I mentioned before, for the next 18 months. Goal number one is an initial internal assessment of current EJ engagement to identify barrier, gaps, and opportunities. On June 15, NASA released a request for information titled Advancing Racial Equity and Support for Underserved Communities in NASA Programs, Contracts, and Grants. The information that we will gather from this RFI will be evaluated and will inform the NASA fiscal year 22 and 23 work plan. Goal number two is the following. We recognize that to expand awareness, accessibility, and use of earth science data to make an impact on EJ communities, the first step is to build and develop relationships with EJ communities, listening and understanding how to be a better resource for the communities. Over the next 12 months, ESD, the Earth Science Division, will leverage our current partnership with non-government organizations, academia, industry, philanthropies, and federal agencies, as well as explore new partnerships to help integrate earth science data with social science data sets to satisfy community needs. Some examples of existing relationships, to mention just a few, are Mercy Corps, Conservation International, Thrive and Air Exchange, Groundwork USA, DOE, EPA, among others. The next goal is to host accessibility and utility sessions with key Earth Science Division providers. For example, the Earth Science Data System Program, who supervise and manage the life cycle of about 50 petabytes of Earth Science data from acquisition, processing, up to distribution, It's one of the key providers. One of the data centers is the Socioeconomic Data and Application Centers, or SEDAC. Since 1990, SEDAC mission has been to facilitate the analysis between the physical and social sciences and support applies research, operational, and decision-making communities. The SEDAC user group represents a range of social and natural science disciplines and other groups from the public and private sectors. The main objectives of these sessions will be to identify current SEDAC data set useful for EJ activities, but also current earth science data sets that are in usable formats for social scientists, and identify potential earth science data set that could enable social science research. The last goal is to enable transdisciplinary science that integrates physical and social science using NASA data sets. In other words, make NASA data more meaningful, available, and discoverable to social science researchers. And how? First, the Earth Science Division will work to increase awareness of NASA data and models through our open source science initiative to make the data more interoperable, transparent, usable, and open. Actually, we are getting ready for the Year of Open Science in 2023. A series of activities designed to support and strengthen other NASA Science Mission Directorate initiatives on inclusion, diversity, equity, and accessibility, and the current work that we are doing on environmental justice. On the one of the main objectives of this open source science initiative is to broaden participation in science and empower historically excluded groups and institutions. Another activity that is aligned with open source science is Unbound. In other words, uncovering needs to broaden outside use of NASA data. This is a series of workshops to engage with communities that are not currently using NASA data. And last but not least, we will also build on NASA tools for outreach and capacity building. Now that I talk about our goals for the next 18 months, the second half of the presentation is on how we can connect NASA data to environmental justice. For that, I'm presenting some examples, some use cases that help us have a deep understanding of the issues to inform decision makers. For reference, all the data sets used are at the bottom of each slide. The first use case goes close to home: Hurricane Maria and electricity recovery in Puerto Rico. As you might know, Hurricane Maria, a Category 4 hurricane, made landfall in Puerto Rico in September 2017. It destroyed thousands of homes and business, killed nearly 3,000 people, and caused the longest electric power blackout in US history. NASA researchers combined satellite data with OpenStreetMap data to monitor where and when electric power was restored, as you can see in the before and after images. They also analyzed the demographic and physical attributes of neighborhoods affected by the power outage. The analysis by Dr. Miguel Roman and colleagues found that 41% of Puerto Rican's rural areas experienced prolonged periods of outage compared to 29% of urban areas. In the 6 months after Hurricane Maria, Puerto Rico lost an estimated 3.9 billion hours of access to electric power, and rural communities accounted for 61% of the loss. In the center of the island, some residents went without power for more than 120 days, my family included. Next, we are moving to Norfolk, Virginia, and sea level rise. In 2017, NASA's disaster program started a project called Communities and Areas at Intensive Risk. The project goal has been to reduce disaster risk and build community resilience around the globe. One of the domestic partnerships focused on the resiliency of the Hampton Roads region. The team developed models and tools that are used by the city managers for planning road work, budgets, and zoning restrictions in flooded areas. Pairing data from NASA satellites with socioeconomic data from CDAC, like population and U.S. Census statistics of race and poverty level, can indicate the disparity between communities being impacted, which can be integrated when making decisions about mitigation strategies. Another example is the Navajo Nation and water resources. Thanks to the recent NASA-developed program effort, the Navajo Nation has now a new computer application, the Drought Severity Assessment Tool, that integrates precipitation data from NASA and other sources to quickly give the Navajo Nation resource managers near real-time data about their water resources. Thanks to the development of this application, the NASA Western Water Application Office continues this effort through the Navajo Nation Drought Project. The project aims to provide the Navajo people with useful data to better manage their water resources. The original tool is now called the Drought Severity Evaluation Tool, which includes even more NASA satellite data, not only precipitation index, but also vegetation index, water indices, surface reflectance, among others data sets. Next, we have air quality and public health. Here we have two examples. First, the NASA's Health and Air Quality Applied Science team is developing a project which will enhance the ability for stakeholders to map environmental justice for various environmental exposures. Specifically, this project will identify communities disproportionately affected by environmental health risks. They will also build capacity among the EJ communities for using and interpreting satellite data sets. As an example, in the image on the right, we can see pollutants exposure over New York City from aircraft measurements and also satellite. In addition, just recently, NASA, ESA, and JAXA, the three space agencies, held on an Air Observation Dashboard Hackathon to solve 10 challenges related to the COVID-19 pandemic using data from the Air Observing Dashboard. The Air Observing Dashboard is an interactive data resource that gives the public and policymakers an unique tool to analyze the short-term and long-term impacts on the pandemic-related restriction implemented around the world through the lens of Earth observation satellites. One of those challenges was related to environmental justice. The purpose of the challenge was to use remote sensing data and satellite image to help form a better understanding of trends as affected by COVID-19 and to analyze how human activity in communities of minority, low-income, tribal, and indigenous populations changed as a result of COVID-19. Here we are also showing pollutants over New York City as an example. Urban heat islands are also an increasingly important issue faced by many communities. Different municipalities, urban planning firms, and nonprofit community organizations have used the NASA-developed program to assist them to better understand the impact on the urban heat island effect. Within the past year, the NASA-developed program has worked with 5 different communities to characterize urban heat effects on and the associated vulnerabilities. The communities include Austin, San Diego, Temple, Sacramento, Cincinnati, Ohio. In fact, in Sacramento and San Diego, the ward informed their state-minded city climate action plans. Another use case is extreme heat in New York City. Combining different satellite data sets can help cities mitigate the heat stresses for residents, especially in warming climates. In this case, NASA Earth Science Health and Air Quality Program worked with the New York officials and scientists to find when high temperatures started to affect human health in New York State. The results showed that New York State's threshold for alerting the public to extreme heat events needed to be updated. The research found that the health effects associated with the temperature in the region actually occurred at lower temperatures than the National Weather Service criteria. NASA then worked in collaboration with the local National Weather Service to update the threshold. Additionally, one of the scientists, Dr. Brennan, highlighted the need to understand the distribution of heat within a socioeconomic lens. He said, and I quote, "It's not a coincidence that some communities are taking on a disproportionate burden when it comes to extreme heat. We have this amazing opportunity to use all the data sets at our disposal to undo some of this inequity and create equity." Dr. Brenner is currently working with the city officials on land cover strategies to mitigate heat. I also wanted to mention the Citizen Science for Air System program. This program supports projects that are making a difference in environmental justice. Here are some examples. First, the lake observations from Citizen Science at satellites. They extended the resolution and coverage of lake in Bangladesh, which are also important for drinking water, flood control, and food, especially in underserved communities. Findings have triggered Bangladesh to invest in a countrywide network of 50 gauges to monitor the impact of the Delta Plan 2100. Second, community eyes on river ice. This project will produce a long-term data set to inform tribal climate adaptation planning for changing river ice conditions and promote project involvement and the data set through the Alaska Tribal Resilience Learning Network. And third, as part of the Air Quality Citizen Science Project, a team is recruiting citizen scientists, including those in environmental justice communities, to deploy a low-cost fine sensor network. Participants are located in EJ communities disproportionately impacted by major source of air pollution. Lastly, on connecting NASA data to environmental justice, I wanted to mention the data pathfinders. The data pathfinders guide users through the process of selecting data sets and learning how to use them with the intention to have equal and open access to NASA Air Science data. We have pathfinders on multiple real-world topics that provide data that can be used to understand possible environmental injustice around the world. Here are some resources that you can use, and of course we are here to help and answer any question. And as a final message, I wanted to say, in general, when we talk about equity and environmental justice, it is quite a challenge, and there is a lot that we can do, and there's a lot to do. It has multiple dimensions and requires a lot of work and collaboration across multiple sectors, including engaging and empowering communities. As a federal agency in NASA Air Science Division, we are committed to listen and understand how to be a better resource for the communities. We are committed to expand awareness, accessibility, and the use of air science data to inform decision makers. We will love to learn more about NOAA efforts and also learn how we can help and how we can work together. That's all for me. Thank you.
Thank you so much, Dr. Luna-Cruz, for that comprehensive assessment of all the things that NASA is doing and some of those things in collaboration with NOAA to really tackle climate inequity and bring justice to the environment and those particularly impacted by that, the most vulnerable of us. So next we have Dr. Reed Walker. He is a Transamerica Professor of Business and Public Policy and Economics at UC Berkeley. His research explores the social costs of environmental externalities such as air pollution and how regulations to limit these externalities contribute to gains and/or losses to the economy, with a specific focus on equity. He is the faculty co-director of UC Berkeley's Opportunity Lab, a climate and environment initiative. He is also a research associate at the Energy Institute at Berkeley and a faculty research fellow at the National Bureau of Economic Research. He was a recipient of the Sloan Foundation Research Fellowship and the IZA Young Labor Economist Award. In addition, his work has been supported by the Environmental Protection Agency, the National Science Foundation, the Robert Wood Johnson Foundation, the Sloan Foundation, and the Smith Richardson Foundation. He received his PhD in economics from Columbia University. We'll turn it over to you, Dr. Reed Walker, as you discuss your efforts.
Great, thanks so much, everyone. Can you see my screen? Let's see. Okay. Okay. So I want to thank Yaítza for that helpful presentation, because it really is a useful segue into what I'm going to talk about today, which is a research project that I've engaged with co-authors at Princeton and the United States Census Bureau, where we're combining satellite data and remote sensing products with social science demographic data from the US Census Bureau. So the basically, I don't have to say this to this audience, but there's a very salient narrative that low-income minorities disproportionately live in areas that are characterized by environmental degradation or elevated pollution levels, and that's given rise to the modern-day environmental justice movement. But when you start actually digging into the literature and looking at these studies, you quickly start to realize that the existing evidence on environmental inequality is both piecemeal and indirect. And the reason I say that is because, the reason I say piecemeal is because if you're looking at ambient pollution exposure, typically doing so using EPA ambient pollution monitors, there's only 775 counties in the United States that actually have an EPA pollution monitor. And as a reminder, there's over 3,000 counties in the United States. So there's a vast portion of the United States that doesn't have a single EPA monitor with which to monitor air quality. And as a result, people have recognized these limitations and have relied on what I would call indirect proxies for pollution exposure. Maybe whether or not a community is proximate to a toxic plant, or a plant that releases toxic emissions. But as we know, wind transport and other things kind of sever the connection between, say, proximity and actual exposures. And what we'd like to measure is exposure and the disproportionate exposures that different communities face in the US. And so what I'd argue is that there's very little evidence on population-wide patterns in racial pollution disparities or the underlying drivers of these patterns, and that's what really motivates this research study. So just to kind of drive home what I was talking about, this is a map of counties in the United States that have an EPA pollution monitor that monitors fine particulates, PM 2.5. And as you can see, there's a lot of areas in the United States that have that are gray. Those are areas that don't have a pollution monitor. The areas that are red, pink, or salmon colored have a pollution monitor, and the areas that are darker red are higher particulate levels than the light pink. Now, as Yaítza was mentioning, there's really enormous opportunities that exist increasingly every day, connecting spatial, say, satellite measurements or remote sensing measurements, and using those tools to try to understand pollution exposure as one example on a nationwide and spatially continuous basis. And the reason that's exciting and enticing is it really solves both of these issues of both kind of indirect measures, but also representativeness, in the sense that we can now measure for the entire nation at a given point in time or over time. And what these new data allow us to do is to explore kind of to what extent does spatial granularity of exposure, basically being able to measure precisely on a 1 kilometer grid of the United States, to what extent does that alter our understanding of questions pertaining to environmental inequality? So just to give you a lens of what the difference is in what we're measuring, this is a data set produced by some researchers at the Harvard School of Public Health using machine learning methods to predict, combined with satellite imagery, to predict particulate exposure on a 1 kilometer grid or raster throughout the entire United States. And so you can see that there's a lot of spatial resolution here, especially when we go back and compare it to the original map that I showed you before. And the idea of this study is basically to merge this information with very fine, detailed census demographic information and try to document patterns in environmental inequality as it relates to particulate exposures. And so this project really has 3 parts. The first part is very descriptive in nature, where we use this data to document black and white differences in particulate exposure and trends over time. The second part of the paper is just trying to understand, well, are there explanatory factors that we have in the demographic survey data that we use that maybe attenuate some of the gaps that we observe? I'll talk about that in more detail. And the last part of the paper is trying to understand some of the explanations behind some of the patterns that we observe. Notably, we've seen a pretty strong convergence between pollution exposure between blacks and whites from 2000 to 2015. And the question is why? And so I'll have some answers to that. So the data that we're going to use in the demographic side is an administrative version of the Decennial Census and American Community Survey. I say administrative version because this requires us to go into a secure federal research data center and use this data because it has very specific geographic detail on where people live and the census respondents, all the way down to the census block, or you can think about effectively having a household address for 32 million individuals that responded to the decennial census and the American Community Survey. And that survey gives us information on race, income, education, family size, whether or not you're a homeowner, et cetera. And we're going to connect all of that data to that PM 2.5 satellite-based measure of pollution from the D et al. Study that I showed you the image from before. And you can think about this as like a 1 kilometer raster or grid of the entire United States. And so now we can measure for every single one of these 32 million respondents what particulate levels were in the given year that they responded in the given block or census block group that they live in. So just in terms of findings, this is a graph that's just showing you time trends. So the average exposure for African Americans in red, and the average exposure for non-Hispanic whites in blue for particulate matter or fine particulates. These are particulates that are harmful to breathe, harmful for human health, lead to increases in mortality and morbidity. And as you see in this graph, the mean exposure, if you just look at the year 2000, which is the, I guess you can't probably see my cursor, but is higher for African Americans. It's about 15 micrograms per cubic meter. Whereas in 2000, the average exposure for non-Hispanic whites is about 13 micrograms per cubic meter. So there's about a 1.5 microgram per cubic meter difference in exposure for the average African American compared to the average non-Hispanic white. But you'll see over time as you kind of move from left to right along the graph that that gap is kind of narrowing over time. And by 2015, the gap is only 1/2 microgram per cubic meter. So there's been a pretty significant increase in average exposure, or increase in the relative gap, or decrease in the relative gap between African Americans and non-Hispanic whites. Since we have all of this microdata for all of these individuals, we can actually look at the entire distribution and like where in the distribution African Americans of particulates African Americans live compared to non-Hispanic whites. And not surprisingly, based on what I showed you before, African Americans live in more polluted places relative to non-Hispanic whites, but that pattern has changed over time. So if you look at the 2015 distribution, the means are quite a bit lower, and the distributions between African Americans and non-Hispanic whites look relatively more similar than they did in 2000. Now, one thing that we do in the paper is just try to understand, are there any correlates that might help explain some of these gaps? And the reason we do this is because within social science, there's a salient narrative that environmental justice or environmental inequality is really a story of economic inequality. If we could kind of flatten the economic inequality in the United States, then that would solve a lot of the environmental justice issues. Now, I think that's a very simplistic narrative, but one way of kind of asking whether or not, one question that people often have is, well, if we were to say give low-income and or minority communities the same income levels as say non-Hispanic white communities, would those people choose to live in different locations or cities in ways that would expose them to less particulates? And so a different way of asking that question is, if I look at the gap between African Americans and non-Hispanic whites in pollution exposure, if I control for the fact that they have different incomes on average, does that do anything to attenuate these gaps? And so we do this with a simple ordinary least squares regression model and just look at whether or not the gaps between pollution exposure between blacks and whites changes when we control for observable characteristics that may differ between these groups, like income or schooling or home ownership status. And the answer is not really. These individual correlates or individual demographic characteristics do very, very little to explain the gaps between pollution exposure between blacks and non-Hispanic whites. And that's true in every single year that we have data. So the question is, well, another question that arises that I said that we were going to explore is trying to understand, well, what is causing these changes in gaps over time, or this narrowing in the gap over time between African Americans and non-Hispanic whites? And really, it's a story of, there's really two candidate hypotheses that come to mind. One is, if you've been following the demography literature or just understanding what's happening in cities over time, in the past 20 years, cities have certainly gentrified quite a bit more, and researchers have documented this, a relative influx of non-Hispanic whites back into city centers in ways that would increase that group's relative exposure. And proportionately, African Americans have been moving somewhat out of cities. These effects are fairly small, but it's true that the relative migration patterns have changed over time. And the question is, well, to what extent do those relative migration patterns explain some of the narrowing of the gap that we observe in the data? And we explore that question formally by just looking at what happens to, by basically thinking about the data that we have in the year 2000, where we can measure gaps in pollution exposure. So that's basically the first column. So the average exposure for African Americans is 14.5, and the average exposure for whites is 12.9, and the average gap is 1.5. And by 2015, you can see in the second column that that gap has narrowed. And some of that might be because people have moved to different places, or some of it might be because those places disproportionately cleaned up. So what we do in the last column is say, well, we know where everyone lived in 2000. Let's just not let anyone move in our data and assign 2015 pollution levels to where you lived in the year 2000 and see what the gaps would have been in a counterfactual world where no one was able to move. And what we see is that if no one was to move between 2000 and 2015, the gap in pollution exposure would be 0.6, and the change in the gap would be 0.8. And so that suggests that while there is some truth to this story that whites are, say, moving back into cities relatively more, exposing themselves to higher levels of particulates, it's not a really central explanatory factor for what's the lion's share of this convergence between African Americans and non-Hispanic whites over time. Instead, what's happening is that the places where African Americans live are cleaning up faster than non-Hispanic whites. And the question then becomes, well, why is that the case? So one hypothesis that we explore in the paper is that environmental policy in the United States disproportionately targets and improves areas where African Americans are overrepresented. And by that, I mean the Clean Air Act, which is the largest and most important environmental policy in the United States, is really a targeted policy that only targets the most polluted places in the country the places that violate the EPA's national ambient air quality standards for the pollutants that they regulate. And so what we want to do is try to understand how the spatial targeting of the Clean Air Act and the standards under the Clean Air Act have disproportionately affected African Americans relative to non-Hispanic whites. And the reason for that is because, as I showed you before in earlier figures, African Americans live in areas that are more polluted, and these are the areas that are specifically targeted by the Clean Air Act, relative to more rural areas that receive much less regulatory attention from the Clean Air Act. So just to kind of give you a sense of how the Clean Air Act works, the EPA sets maximum allowable concentrations of air quality for certain criteria air pollutants. These are pollutants that are harmful to breathe, harmful for human health. And these regulations are enforced at a county by pollutant by year level. So if your county or region, the air monitor exceeds the threshold for the ambient air quality standard, then that region is designated as non-attainment of the standard. And areas that exceed the EPA standard, the areas that are designated as non-attainment, a lot of things happen. There's new limits on how much pollution may be allowed. Firms are required to install more stringent pollution abatement technologies, and any new sources of pollution basically have to offset their emissions by reducing pollution emissions from somewhere else within the county. The reason that we're focusing on these standards in the Clean Air Act in particular is that in 1997, the EPA introduced a new particulate matter standard, and that was litigated quite a bit in the courts, but finally rolled out in the year 2005. And in 2005, 200 counties found themselves newly designated as non-attainment for PM 2.5. And what we want to do is explore how this designation disproportionately affects different communities in ways that might help us understand what's leading to the convergence in outcomes and PM 2.5 exposure, relatively speaking, between African Americans and non-Hispanic whites. So this is just a figure showing you the orange counties are the counties that were designated as non-attainment for this particulate matter standard. And these are the areas where the EPA basically forced communities to clean up particulates in a variety of ways. So what we do is basically try to compare trends in particulate exposure in the orange counties to trends in particulate exposure in the gray counties as kind of a natural experiment where we try to understand whether or not these orange counties are cleaning up much quicker than the blue or than the gray counties. And what this figure is showing you is the difference in air pollution exposures comparing orange counties to blue counties or to gray counties over time. And what you see is that in the years after this regulation went into place, air quality in those orange counties improved significantly relative to the gray counties in the years afterwards by about 1.5 micrograms per cubic meter. Now, the reason that's important is because the Clean Air Act, those orange counties, are really the dirtiest counties in the United States as measured by particulates. And these are also the communities that African Americans disproportionately live in. And so what we want to do is explore how the Clean Air Act not affected basically mean exposures, but other parts of the pollution distribution in ways that might have implications for where these individuals live, or for where that might have implications for the black-white pollution gap. And so what we show is that the Clean Air Act, those basically chopped off the top of the distribution and had very large treatment effects in the middle part of the distribution. That's lowering pollution exposure significantly for the communities in the upper part of the pollution distribution, communities that are overrepresented by African Americans in our data. And so one way to think about that is if we think about what pollution exposure was in 2015, that's what I'm plotting in blue. And then you can think about an alternative world where we didn't have the Clean Air Act PM 2.5 regulations, and this is what the distribution of pollution exposure would have looked like. And so what we want to do is to try to think about, well, in that world where we didn't have these new regulations go into place, what would the gap in pollution exposure have been for African Americans when we compare them to non-Hispanic whites? And how much has this regulation really driven some of these, some of the convergence that we observe in the data. Just as a reminder, the tan bars here are the communities where African Americans disproportionately live. And if we go back, we can see that the difference between the orange and blue bars here are what happened because of the regulation. And so what we want to try to do is map some of these differences into these population shares where these communities disproportionately live, to try to think about how policy has affected exposure gaps between African Americans and non-Hispanic whites. So we do that. I'll spare you the details, but basically what we can say in the paper is that about 60% of the narrowing that we observed from 2000 to 2015 in particulate exposure between African Americans and non-Hispanic whites can be explained by the regulatory variation in the Clean Air Act's National Ambient Air Quality Standards for particulate exposure. So just to sum up and to clarify a little bit, I realize I went very quickly through the explanations, but a salient feature that we've observed in our data is that the relative gaps in pollution exposure, or call it environmental inequality, between African Americans and non-Hispanic whites have narrowed over time significantly. This is not really due to the relative differences in migration. Instead, it's Black communities are cleaning up more rapidly than white communities. I want to be clear about one particular nuance of this, is that it's the cities where African Americans disproportionately live, not the neighborhoods per se. So it's not like the Clean Air Act is disproportionately cleaning up Black neighborhoods in Pittsburgh relative to white neighborhoods in Pittsburgh. It's not doing that. It's disproportionately cleaning up Pittsburgh, which is an area that has a relatively high African American population share. And so it's those cities that are experiencing across the board improvements in air quality are disproportionately overrepresented by African Americans. And that is what's leading to the narrowing of these gaps in the data. We have a bunch of other follow-on projects that are very much in the spirit of what Yaítza was suggesting earlier, where we're connecting the satellite imagery to very fine-scale administrative versions of the decennial census and doing some other demographic work, exploring patterns of environmental inequality for different racial groups and thinking about intergenerational trends as well. And I'd love to chat offline if anyone has questions, but I appreciate the opportunity to talk about my work.
Excellent, thank you so much. And I invite Yaítza to come back as well. These are fascinating and very important presentations. And audience, we're going to now take the next 10 minutes to answer your questions. So please type them in the questions chat box in the control panel, and make sure to let us know to whom the question is addressed so that we can, I can send them to the right person. But before I start reading questions, I want to encourage you to download the slides from our speakers' presentations. You can also find them in the handouts drop-down menu in the control panel. So let me open up the questions. Give me one moment. And we have 2 questions so far. This first one is addressed to Dr. Walker and asks, with the limited number of PM 2.5 monitors available, how is attainment/non-attainment defined in the many counties that do not have monitors?
It's a great question. It's a little bit of a chicken or egg problem, I guess. The EPA, so I think the easy answer is that areas without monitors cannot be in non-attainment. I'll put that in air quotes. There's a little bit of slippage in that because the way that non-attainment is designated is what's called an air region. So think about that as a metropolitan statistical area or like a city. So like New York, the non-attainment area around New York includes Manhattan, Brooklyn, but also parts of Connecticut and New Jersey. And so you could be a county that doesn't have a monitor adjacent to a county that's in violation. And if the EPA designates that whole region as non-attainment, then you're a non-attainment even though you don't have a monitor. But the reality is that, and the EPA knows this, we have far fewer monitors than we should have. I mean, in the past 5 to 10 years, we've seen a tremendous amount of low-cost monitoring technology, call it purple air or whatever it is you want to use. And there's so much spatial granularity even within a city or a county, and we're just missing all of that by using these very limited monitoring network that the EPA currently has.
All right, thank you for that response. This next question is for Dr. Luna-Cruz, and it asks, how does NASA collect user information? Any tips for NOAA on collecting user information from underrepresented and underserved communities? What is NASA's definition of capacity building, and does NASA have a formal capacity development strategy? It's a big one.
Okay, yeah, it is a big one, and I think there's like 3 questions in one. Like the first one, the first one was how we collect data from the users, right? So the Air Science Data System Program, they regularly do a survey for the users, and we collect metrics that help us understand what users are actually reaching out the data, and that's why we are now like in a phase that we want to reach more people, because we are using the data from that users survey. And the second question was, I totally forgot about the second question. Can you repeat the second part?
Sure. Any tips for NOAA on collecting user information from underrepresented and underserved communities?
Yeah, I think it's reaching out and actually going to the communities. It's a good exercise. That's why we are planning to have these listening sessions with the communities. And there's a lot of non-government organizations that help us to reach out the communities, as the examples that I provided. So it's just actually reaching out and listening and understanding what are the community needs. So I think my recommendation for NOAA is just go out there and make the communities part of the solution. Yeah.
Excellent.
And
thank you so much. The last part. It's actually 2 parts. What is NASA's definition of capacity building? And does NASA have a formal capacity development strategy?
Yes, we do. We do have a team that it's like Nancy Survey that I mentioned. She's responsible for the capacity building. So she connects with a lot of communities. So capacity building, we are talking about summer camps. We are talking about training, different activities, tiger teams, etc. So we do have like capacity building in NASA. Of course, we are not perfect, we are learning. And I think that the most important thing is that we are engaged now and we are committed to do more capacity building with the EJ communities.
Excellent, thank you for that response, that really big question. This next question is for Dr. Walker, and it asks, what were the causes of the pollution?
Yeah, I mean, so fine small particulates, PM2.5, come from a variety of sources. Some of it is industrial emissions, like manufacturing. A lot of it can come from road networks. A lot of it actually can come from agriculture. And most recently, and this is something that's become more salient in the past 5 years or 5 to 10 years, is wildfire smoke. Although the EPA specifically prohibits non-attainment designations based on exceptional wildfire events, although I think they're going to have to start rethinking some of those designations, given that in the past, there's been a recent study that in the past few years, a majority of fine particulate exposure is starting to come from wildfire smoke. And so if the EPA and the Clean Air Act formally ignores that, then that's a problem because this is a public health hazard and concern. But yeah, the primary precursors typically come from industrial emissions and roadways.
Excellent, thank you very much. Next question is for Dr. Luna-Cruz, and it asks, is there a social science committee or other such venue to bring together NASA social scientists?
So as I mentioned before, we have a data center, is the socioeconomic data and application center, CDAC. They have a user working group, which is like it's a range of different public and private sector researchers that are part of the CDAC group. I think that's a good resource for social scientists to go to the to this data center and talk with the NASA scientists over there, because they have a lot of data, and they work together with actual NASA scientists to integrate the physical science with the social science researchers.
Thank you. We're going to ask this last question, and it's directed at Dr. Walker. It asks, it's actually a big one. How can this empirical approach help inform vulnerability planning for underserved communities? For example, unequal impact of wildfire smoke. Is there evidence that the Clean Air Act is having a smaller impact over time? In other words, is it getting harder to clean up the more polluted areas over time?
Yeah, that's a really good question, and it was related to the last response. I mean, there is recent evidence published in the, I think it's a Proceedings of the National Academy of Sciences, suggesting that a larger fraction of precursors to fine particulate exposure comes from wildfire smoke, which is something that's unregulated under the Clean Air Act, and thus is not going to be something that the Clean Air Act is designed to address. And so in that sense, I think it will become harder unless the EPA thinks about other strategies. The other thing is that the EPA, I think the Clean Air Act in general is poorly suited for thinking about within city differences in pollution exposure. The whole national ambient air quality standards are ambient in nature, so they're designed to measure background pollution levels for the entire city. And as I suggested earlier, low-cost monitoring technology, satellite imaging, and others are starting to reveal that there are huge disparities in pollution exposure even within cities. And some neighborhoods within cities might have 10 to 12 times the exposure levels that other neighborhoods have, and that's not going to be surprising, I think, to people that have followed the environmental justice literature per se. But it just, I think, requires new approaches with this recognition of all of this spatial heterogeneity or granularity or differences within neighborhoods. The Clean Air Act is just not well designed to deal with those issues. The last thing I'll say is that the Clean Air Act has been around since 1970, and it's been primarily regulating industrial emissions. I mean, it has something to say with transport emissions, like with emission standards for cars, but the car emission standards are national in nature. And I feel like, and this is now a personal opinion, the EPA has been really ratcheting down things for industrial emissions, and the last mile problems, a lot of the most pernicious problems for particulate exposures are really coming from highways and communities that live around highways, because we could do a lot more with industrial emissions, but we could do a lot more with highway emissions and transport emissions, which are some of the largest precursors or the largest contributors to local air quality problems in a majority of these communities.
Excellent. Thank you for answering that question. And that question actually will conclude our webinar. I'd like to thank you both, Dr. Luna-Cruz and Dr. Walker, for your fantastic presentations and adding to this wonderful conversation about environmental justice. And I'd also like to thank Michael Smith and the Office of Performance Risk and Social Science for organizing this series. Just as a reminder, the recording for this webinar will be available later today on the NOAA Central Library YouTube channel. So please let any interested colleagues know about it if they could not join us. And also, there is a playlist for this series. So if you'd like to watch any of the previous 3 webinars, please do so. NOAA Central Library is very proud to host presentations like today's that feature the work of NOAA community members and its partners. So thank you for joining us, and be well, everyone. Take care.
Thank you.
Thank you.